ALS looks and progresses differently for every person. Some people may progress fast, others may progress slowly. Some people's symptoms start in their arms or legs, others start in their neck and head. Scientists still do not understand the underlying biology behind the disease or why it can present so differently between cases. This makes finding effective treatments difficult because what is effective for one person with ALS might not be effective for someone else. Take, for example, Amir and Beth. They both have ALS. Amir carries an inherited ALS-related gene and is a fast progressor whose symptoms began with trouble speaking. Beth has no family history of ALS and is a slow progressor whose symptoms started in her legs. Understanding what makes these two cases so different could help researchers better understand how to develop effective treatments for people like Amir and others like Beth. Your data could be the key to understanding these differences and finding effective treatments. That is why the ALS Therapy Development Institute created the ALS Research Collaborative, or ARC, the most comprehensive natural history study in ALS. ARC aims to learn more about this disease by partnering with people with ALS around the world to gather comprehensive data. Data collected through ARC is then used to inform research efforts at ALS TDI and is shared with the ALS research community to help advance the understanding of ALS. ARC participants like Amir and Beth can contribute data for the study in 5 main ways, all of which are optional and can be submitted from home. They both submit scores from the ALS Functional Rating Scale, or ALS-FRS-R, a questionnaire used to rate a participant's physical ability after the development of symptoms. They also answer questions about their background, lifestyle, and other factors that may contribute to the development and course of the disease. Every month, Amir calls in to make a recording of his voice. These recordings can help us measure the changes in his speech over time, using machine learning models developed in collaboration with Google. Beth regularly completes a series of guided exercise with wearable accelerometers, helping us to track her limb strength over time. A phlebotomist comes to Amir's home every 3 months, collecting blood samples to be sent to ALS TDI. These samples are used for biomarker discovery, whole genome sequencing, and other research to help us better understand the biology of ALS. Beth and Amir, like all ARC participants, can access all the data they've contributed on a private, personalized dashboard. They also may share this dashboard with their healthcare team to help make informed decisions about their care. By collecting information in all these different ways, ALS TDI scientists can start to tackle the complexity of ALS. We can investigate questions like, is there a certain genetic mutation associated with fast speech progression? Or is there a biomarker that is associated with the faster spread of symptoms in the limbs? The answers to these questions can help us better understand the different types of ALS, so we can develop more targeted treatments for people like Amir and Beth, and design clinical trials around their specific presentations of ALS. The more data that we can gather and share with the global research community, the better the chances of finding effective treatments for everyone with ALS. We hope that you will consider becoming a part of this global effort to end ALS.